Welcome, Chapter 7, Telecommunications, the Internet and Wireless Technology. Our learning objectives. What are the principal components of telecommunications? How do they work? What are different types of networks? How does the Internet technology work today in the business world? And the principles of technology, networking, communication, wireless, and Internet access. There's some basic topics. So network and communication trends. Convergence. Basically, that's just the telephone networks and computer networks converging into a single digital network using the Internet. Standards, right? We have standards for everything that we're going to be looking at. We have broadband. What do they say? More than 74% of the U.S. Internet has broadband. Think of the difference as regular telephone dial-up, a Route 46. Broadband's kind of like a Route 80, just a lot more lanes to get on it. The next thing we're going to be looking at is broadband wireless. Voice, data communication are increasingly taking place over broadband. Excuse me. So broadband is becoming more popular, more prevalent. So, what is a computer network? Two or more connected computers. So if you have computers at home, you have two laptops, you are a network. So what are some of the major components of it? Client and server computers, NIC cards, network interface cards, connection medium, network operating systems, hubs, and switches. So client and server. So a client is the PC that you use. A server stores all the information. If you're at work, chances are you don't have Word or Excel stored on your computer. Chances are they're installed on a server, which houses everything that you do. So this way you don't have to worry about backing up your computers, your laptops, or even your desktop. All that information is handled by the server. Now, every device that's on the network has to have a network interface card, whether it's your smartphone, your laptop, and your laptop might even have two. Might have a wireless and a wired NIC card in it. Every NIC card in the world is unique. How do we connect? Well, most of us connect through some type of wire if we have a desktop, and wireless if it's not. But that allows us to connect through it. And when we connect to it, we connect to the network operating system. And the network operating system allows us to put in share devices. It's where we store our data. It's usually password protected. And that allows us to have all our information whenever we need it. And that's made up of a bunch of hubs, switches, and routers that protect our data. That is our protection. That is what we provide our information on. So usually networks in large companies, hundreds of computers are connected to it through a local area network or a LAN. They have very big servers, usually have multiple CPU servers that allow us to have this information in it. We have websites, we have intranets, extranets, and back-end systems. We also might have Wi-Fi, video conference systems, telephone networks, wireless cell phones. This is all what large companies have. So what is it allows our employees to do what the job they need when they need to do it. So the client-server computing, it's a distribution model. And basically, as I mentioned before, we have one server, all the information's on it, and it allows us to connect to it. And it stores all our data. So we don't have to worry, where do we put that file? If my computer crashes, we know it's up on there. So we don't have to worry about it. Now, networking uses something called packet switching. And think of it as a UPS package. So if you're going to ship 5 UPS packages across the country, you're going to label them 1 of 5, 2 of 5, 3 of 5, and so on. Well, packet switching is basically, that's how this works. When you send out anything through the internet, even a command to get onto the web, it sends out it breaks everything up into small packages that are managed. And it says, yep, we sent out 25 packages. This is 1 of 25, 2 of 25, and so on. It goes across the internet. And they can all take different paths. It's never the same path. But when it gets to the end results, it puts it back together. And it waits till it has all those packets back. If it's missing a packet, kind of sends out a little search. Hey, I'm missing this packet, and it looks for it, kind of like the trace on how that works. And that is the backbone for packet switching, how our network works. Now, one of the things with mobile communication is the first three generations didn't allow mobile phones to packet switch. It's not until they went to packet switching that has allowed the mobile devices to actually use the same technology that the internet uses, your computer uses. And that allows us to get the internet now on our phones because it's switched to the same type of information. The other network protocol that we use is TCP/IP, and that stands for Transmission Control Protocol, Internet Protocol. And that gives us the governance, and it's a standard that we're used. And basically, there's 7 layers of it that are used. Our book talks about the basic 4 layers: the application layer, transport, internet layer, and network layer. And these are the layers that each layer has to build up. And these are built into our NIC card if you want. And they have to go through all these layers in order for it to communicate. The application layer is the layer that we see at our things, at our phones. So we do have different networks going around. We have a digital, what's the difference between digital and versus analog? Well, digital is what our computer uses. And every time we see a picture on our screen, that is digital. Every time we type the letter A, it is digital. And digital, all it means is it's on or off, 1 or a 0. And that is how computers work. However, analog uses sine waves. AM, FM frequency. Well, here's the thing. Our telephones use analog, and our computers are digital. So hence, we have this modem. And that basically transfers digital signals into analog and analog back to digital. Stands for modulate, demodulate. And that allows us to communicate our digital computers over our analog phone lines. Because the phone lines send out the message just like we speak. And the beeps and bops and everything. If you ever heard a modem or a fax machine, that's it. That's digital being sent over the phone lines. And that's how we have to have a modem in between our computer system and the analog telephone lines that we use, the copper lines outside. So different kinds of networks that are available. We've spoken a little bit about the LAN, local area network. It's the size of a small building. And they use basically Ethernet cable. And that plugs in. In the past, there's all different cables, but we just basically comes down to Ethernet. It's the most economical device for us to use. We have client server and peer-to-peer. We have wide area networks, metropolitan and campus area networks, CANs, MANs, and WANs. WAN is the World Wide Web. Metropolitan's a city. Something like Google might have a metropolitan area. They have multiple buildings that have that, and the same with the campus network. It's our campus here at Caldwell. So how do we connect? Well, there's a couple different ways. Twisted pair Cat5 is the most common. It is the most economical. It's easy to run and allows us. In the past, we used something called coaxial cable. Think of it as your cable in your home. Kind of looks like that, major wire. It's not as flexible as Cat5, but it allows us to have it. Now we use fiber optics. Verizon uses this. Well, fiber optics is pretty much in every server room. It connects all your servers. It literally travels at the speed of light. So for having a backbone, it's a good thing to have. Having it run in the offices, it's probably not efficient because of the cost and the fact that it is very susceptible to be broken. Now, we have wireless devices. We use cellular and satellites. Here's the thing. They are slower, but you can connect from anywhere. You do not need a cable. But they do not run as fast as twisted pair or coaxial, and especially not as fiber. So, when we go to cellular devices or wireless, we do lose that speed. Transmission rates, bits per second, PBS, hertz, and bandwidth, as you've heard them, what we talk about. So what is the internet? It is the world's most extensive thing. It has a bunch of ISP providers. Basically, it started out as something as ARPANET with the government, And slowly what happened, all the colleges, MIT and Southern Cal, they say, hey, let's share communications. So it started out as the government network. Colleges took it over, and now it's just literally everywhere, if you have to have an ISP provider or internet service provider to get onto it. The college is one of those. Cablevision, Verizon, they're all ISP providers. So most of the time we used dial-up. That was the old days, and we were limited to 56K. Then we had DSL. We went up to 385 kilobytes. Now we have cable, and that's 1 to 50 megabits per second. Satellite, T1s and T3s. These are just the ways that we connect. Obviously, the faster connections cost a lot more money. So if you have a T1 or T3 in your company, you have a fast connection. It's just you're paying for it. Usually that's not something we'd have at home. Home we use our Cablevision, cable internet connections, which most people have. I don't know of many people running dial-up anymore or even DSL, but that probably about 10 years ago was the most common. Now cable is probably the most common. So you all know the internet devices. If we want to go to Yahoo, we type in Yahoo. Well, behind Yahoo, there's a 32-bit number. It's usually 4 quadrants of 3 numbers. So something like 207.46.250.119 is a set of protocol. Now, back in the olden days, you had to know those numbers in order to get somewhere. This is going back 15 years ago when I started playing with the internet. There was no DNS, or the domain name system, that would convert your IP addresses. So if you typed in Google, if you didn't know the Google 32-bit number, you couldn't get there. Now we type Google in, and there's a little table, if you want, that converts it. So think of it as a database like we talked about last week. So if I type the word Google, it knows where to go. And it's not just one number. They can have a whole bunch of different numbers on how this is all structured. There's a couple things we want to think about. There's a couple professional organizations and government bodies that kind of keep everything in line. ICANN, IAB, and W3C. They kind of put everything together. Now, I talked a little bit about our naming convention where we had 4 sets of 3 numbers. Well, here's the thing. We're running out of them. So now we're moving to something called IPv6, which is 6 quadrants of numbers. And so instead of having only 4, you have to have now 6 in the back. And again, from an DNS number, it's not going to change anything you do, but the back end, the programming, they will have a whole new way of connecting to that information. So what are some internet tools that we use? You've all used email, instant messaging, newsgroup, Telenet. If you do any work transferring files, FTP, and we all use the World Wide Web. And now one of the bigger things is voice over IP. Voice over IP is that digital voice communication using the packet switching again. And again, remember, all this packet switching happens at real time, milliseconds. So it's very, very good at what it does. If you've ever dialed in from work, I say dial in, well, connect from work, my old school. We use a VPN. Usually it's secure. Think of it as a tunnel. It actually puts a pipe through there so no one can see what you're doing, and it prevents anyone from getting into your information. So some of the things that we are going to be looking at: the web, hypertext, HTML, HTTP, uniform resource locators, web services. This all allows us to have this information. So what do we search for? What do you use? Most people use Google. I still like Yahoo. But you can have mobile searches, social searches, is all different kinds of things. Tagging, Pinterest, you know what you're doing for searching. Now when we search, there's shopping bots that allow us to have search engines and marketing. That allows us to have all this different information. So Web 2.0 is the first Web 1 was just informational. Web 2.0 allowed us to share information, creating new services. It was interactive, real-time users, social participation. and user generated the content. We had blogs and blogspheres and microblogs and wikis and social media networking that collected all this information together. Now, what's happening with Web 3? It's more pervasive web. It's the Internet of Things. You put your thermostat online that you can control it from anywhere. You can look at your mobile home, your home, with all the connections, your phone, your cams, your refrigerator. That's the Internet of Things. Internet of People, app, integrate cloud, software as a service. We're looking at all these different things. Greater seamlessness of the web in general. So why do we have, let's talk about the cellular system, different phones. There's basically two types. There's CDMA, which is the United States only, and that's like Verizon. Then you have GSM, and that's pretty much the rest of the world. AT&T uses that, and T-Mobile. And they're on the third generation of networks. Fourth generation 4G uses up to 100 megabits, suitable for internet speeds, and that uses the LTE and WiMAX that we are able to use. We have Bluetooth that allows us to connect our speakers. If you're using an iPod or your iPhone, you have your earbuds. They're Bluetooth. You're connecting your phone to your car's Bluetooth. When you get home, you use the 802.11 standard to connect your Wi-Fi. It connects to our LAN. Again, these are just the standards that are out there that are used. Radio frequency identifiers, RFID. Your Easy Pass uses RFID. Those little close tags when you go buy something and there's a microchip in them. And when you try to walk through the store, it beeps. That's an RFID. I believe the Amazon store that just opened up in New York City uses it. They've put RFID on everything that's in the building. When you walk out, it knows you walked out with it. So these are some of the things that are going to do it. They're extremely used in the supply chain system, which we'll end up talking about later on. So that's basically how the telecommunication systems work with everything. That was Chapter 7. So remember, I hope you enjoyed it. Get out and smile.